Hello, my name is Richard Saunders, and I'll be presenting today on Project Soli. So what is Project Soli? It's a new sensing technology designed by Google ATAP. That's short for Advanced Technology and Projects. Project Soli uses miniature radar to detect human gestures. This means we can be freed from the limitations of a 2D touchscreen. And the beauty of it is that it's small. So small that it can fit on a chipset that can be installed in just about any device. So what does all that mean? That means that the radar in your smartwatch would be able to detect you making a motion like this and respond with the software functionality, such as setting the time, bringing up a menu, or some other feature. Virtual reality experiences could be designed to respond to your actual movements rather than the movements on a thumbstick or controller. As the technology becomes more sophisticated and more affordable, we could expect to see it in everything. Imagine walking through your home and controlling every piece of technology from your gaming system to your kitchen stove to your light switches with touchless gestures. The folks at Google Advanced Technology and Projects believe that the human body itself is the most sophisticated input-output device, and Project Soli is their way of making good on that belief. So how does Soli work? The Soli device uses a miniaturized radar array to send radio waves at a target. The sensor then intercepts and interprets the reflected energy from the target. The Soli team built what they call the full gesture recognition pipeline. This gives them the ability to extract a lot of data from a single gesture at a high frame rate. Motion resolution is achieved by extracting subtle changes in the received signal over time. The technology is now in an alpha developer phase. This means that about 60 developers that Google has selected received kits with the chipset and a hardware-software bundle to get them started. These developers were selected from hundreds of applications and come from 14 different countries. They have used the technology for projects such as 3D imaging and predictive drawing. Other ideas included using Soli to compose and conduct music, as well as security applications. Locks were open and closed using only touchless gestures. The University of St Andrews in the UK used it to identify different materials, such as copper or plastic. While it still has some limitations regarding similar objects and materials that it cannot see through, they are making great progress with this aspect of Soli. They refined this to detect the difference between two different smartphones. It can now detect whether the hand holding the phone is wearing gloves or not, and enlarge the buttons accordingly. This aspect of the technology has endless applications. In one example, a user could hold their Soli-enabled device over their wrist to bring up a clock, or over their stomach to bring up nearby restaurants, or over their shoes to bring up fitness apps. Another application was to have Soli sensors integrated into the tables at restaurants, giving the servers alerts if drink glasses were approaching empty or if the empty place needed to be cleared. These breakthroughs are the results of a method that is called RadarCat, or radar categorization. This system is instantaneous and highly accurate. The radio waves that are sent and received from a Soli chip can be interpreted to create a unique thumbprint of anything that touches the sensor pad. This also creates a huge opportunity to interact with other connected devices. Fast Company imagined a Soli-enabled kitchen that connected to Amazon's Alexa. Soli could identify the ingredients as you open your refrigerator, and Alexa could guide you through the cooking process. If you grabbed the wrong pan, Soli could identify it, and Alexa could offer corrections. A Soli-enabled stove could identify when your sauce is thickened enough and reduce the heat to a simmer automatically. The Soli-enabled kitchen is just one of endless possibilities. Soli chips could be easily used to sort recyclable materials for waste management companies. A Soli radar kit system could have untold potential for assisting the blind in identifying objects in the world around them. Imagine a headset that could tell a blind person not only exactly where an object is, but exactly what it is. What about an array of Soli sensors detecting a surgeon's tiniest movements and which surgical tools he's using, and transmitting them to a robot on the other side of the world that performs the actual procedure on the patient? It's easy to see how Project Soli could easily change the world that we live in. The concepts created by the development teams that Google ATAP has selected are bringing ideas that were once only seen in science fiction movies into the real world. The usefulness of this technology can be imagined from everything from mobile devices to art, dining, security, to even medicine. The best news is that much of this is already a work in progress. While some touchless sensing concepts are years or even decades away, some projects seem to be on the verge of readiness for consumer consumption. I know that I am personally excited to see what innovations will come out of this exciting piece of technology.